There's a whole world deep down the Earth's crust. The majority of people remember learning about the structure of the Earth in primary school when they were instructed that our planet is made up of an eggshell-like crust over a thick mantle that surrounds a super-hot core. This is the only thing that they know about the composition of the Earth. In the past 10 years, scientists have discovered several really interesting discoveries, some of which are extremely peculiar or profound, that can provide additional insight into that image. They have discovered a river of liquid metal that travels faster than the tectonic plates. Bubbles at the boundary between the crust and the mantle, a new species of mineral that is somehow capable of holding water hundreds of miles within the mantle, and chambers of magma where rocks are heating up like popcorn and being expelled. These are just some of their recent discoveries in the Earth's subterranean regions. Comparable to the depths of the ocean, the inside of our globe is quite challenging to research. The investigation has relied heavily on the development of technologies that can detect what lies beneath the surface of the Earth, because humans are unable to penetrate very far into the planet. Definitely not the 3963 miles required to reach its core. When sonar was utilized to image the ocean floor approximately 50 years ago, it was only then that it was determined that tectonic plates existed. Why is it such an uphill battle to venture below? To begin, there is the amount of pressure. Just 8 miles down, you'd feel the weight of 131 elephants pushing down on your head. That's the equivalent force of 131 elephants, and the heat is almost intolerable. About 1600 degrees Fahrenheit can be found on the thermometer when measuring the temperature at the base of the top layer of the crust. In comparison, the temperature at the center of the Earth is estimated to be around 10,800 degrees Fahrenheit, which is equivalent to the temperature at the surface of the Sun. To this day, human beings have only succeeded in tunneling 7.6 miles below the surface. Seismometers allow geophysicists to see inside the Earth in a manner analogous to that of X-rays, which look inside our bodies. We tend to think of the Earth as being quite stable, with the possible exception of when it is struck by an earthquake. Though we live on chunks of crust that are perpetually moving around, performing a dance that we can't feel, but that scientists are always keeping an eye on. As an illustration, the gravitational influences of the sun and moon cause the city of Phoenix, Arizona, to rise and fall by around 40 centimeters twice every 24 hours. In addition, Southern California experiences over 10,000 earthquakes each year, the majority of which are of magnitude 2 or lower. Seismometers are the sensors that record the seismic waves that are produced whenever one of these earthquakes occurs, as well as whenever there is a rise or fall in the Earth's surface. A seismometer is similar to an X-ray machine in that it analyzes the way energy travels through an object to determine what is going on inside that object. At the moment, the Global Seismographic Network, GSN, consists of more than 150 seismic stations that are located in different parts of the world, and the network that is comprised of Incorporated Research Institutions for Seismology, IRS, has more than 250 stations. In 2016, Ed Garnero from Arizona State University School of Planet and Space Exploration, TEDx Manhattan Beach Talk, an extraordinary peek into the center of the planet, and a team used this treasure mine of seismological data to investigate an ongoing puzzle about the mantle. Over several decades, geophysicists found that seismic waves slowed down in 2 regions beneath the crust on nearly opposite sides of the planet, one below the Pacific Ocean and the other below Africa. They determined that each of the masses was enormous, with a size comparable to that of a continent, a height 100 times that of Mount Everest, and a depth of almost 1,800 miles below the surface. In addition to that, they speculated that the regions were exceptionally warm because waves can slow down in particularly warm locations. Garnero and his team of experts were intent on learning more about the situation. They are the largest parts of our Earth that we have identified, but know nothing about, he says. We have no idea what lies beneath them. After analyzing the data, the team led by Garnero came up with a significant finding. The researchers believe that the giant blobs do not simply have a temperature that is separate from the rest of the mantle. They also have a specific chemical composition that is distinct from the rest of the mantle. According to Garnero, we see that the seismic waves that go near the boundaries of the blob split into a wave that goes into the blob and slows down, and a wave that continues along the blob's outside margin and goes at normal speed. We see this because the seismic waves that go near the boundaries of the blobs go near the boundaries of the blobs, he says. Scientists believe that temperature alone cannot do that, so the blobs being compositionally distinct is the easiest explanation. Even though the researchers do not yet know what the masses are composed of, they can discern that the masses are denser and more stable than what is around them. And it's quite likely that they're fueling volcanoes. On Earth, above the blobs, there are volcanoes past and present, ranging in size from small to massive, explains Garnero. For instance, the hotspots that gave rise to Hawaii, Samoa, and Iceland are all supplied with magma by extraordinarily deep plumes that appear to be connected to the blobs. This begs the question, where did these blobs originate from in the first place? The idea that they are leftovers from the origin of our planet is an intriguing notion. This theory proposes that they are relics of some primordial layer of the Earth that was eroded over billions of years due to the power of convection. According to Garnero, our core cooks the mantle rock, which makes up about half of the Earth, from below, causing it to slowly turn and move. If you were to take a time-lapse video of the Earth's rocky mantle throughout millions of years, you'd see it swirling around just like smoke does around a bonfire. And it's possible that some of the stuff got whipped up into the globs that were the size of continents. With the help of the seismic data, Garnero and his team were able to generate fascinating images of the Earth that contain the mantle blobs. These images provide us with what is effectively an MRI of our planet. Exploring the depths of the planet is an experience that Garnero hopes to convey to the general audience. Recently, he collaborated with a group of artists from Arizona State University, led by Lance Garavi, to develop Beneath a Journey Within, a film music and dance performance to immerse the audience in seismic data. Garavi served as the event's artistic director. Exhilarating, in Garnero's opinion, has been the multidisciplinary collaboration. The scientists give the artists a platform to create, and then the artists give the scientists a new way to see their data. The event is being staged within a 3D theater on campus, and it featured artists such as a bass-playing geophysicist who interacted with his data through trip-hop bass lines, and a belly-dancing theoretical astrophysicist who embodied seismic waves. The next step for geophysicists is to compile data from seismometers located all around the world to contribute to the growing body of underground information. Titan, one of the world's fastest supercomputers, was used by a team from Princeton University in 2017 to produce a highly precise map of the interior of the Earth. Titan is capable of performing over 20 quadrillion computations per second. As for Garnero, he has aspirations that span the cosmos. To get the most detailed information out of seismic data, he says, he and his students are currently working on it. This includes revisiting an earlier study of the Moon that revealed it had a solid iron-rich core. Additionally, his division is working on the creation of a miniature seismometer for NASA to take on a journey to the moon Europa of Jupiter. This seismometer would record vibrations on Europa's crust and attempt to locate as of yet undiscovered reservoirs of water beneath the moon's icy veneer. According to Garnero, the process of designing such a gadget is not a simple one. Because seismometers are such sensitive pieces of apparatus, the one that would be used for extraterrestrial travel would need to be built to withstand the rigors of a hard spaceship landing, as well as the other challenges that come with such journeys. Do you like it? Kindly give your valuable response in our comment section below, and don't forget to subscribe to our YouTube channel for more interesting and informative videos.